Alright, good morning everyone. So today we're going to be taking a look at section 8.6, which is radical equations and problem solving, which just means word problems. Okay, so the first thing that we want to take a look at today is what's called the power rule. And basically what the power rule says is that if you raise both sides of an equation to a power, so for example, if you square both sides of an equation, or maybe you cube both sides of an equation, so you raise it to that exponent, all the answers that you get are among the answers that you get for the new equation as well. What happens sometimes is that the answers that you get for that new equation are not always the answers of the original equation as well. Sometimes you get what I call a fake answer, and that's what we call an extraneous solution. It's when we get an answer that we plug in to check to the original equation and it doesn't work out. So every time you square or you cube or you raise both sides of an equation to some exponent, you always have to check your answer now. It's part of the process because it is very possible that you could get an extraneous solution. Okay? And sometimes maybe one of your answers will be extraneous, maybe all of your answers will be extraneous, and maybe sometimes none of your answers will be extraneous. Every case is different, and you just don't know until you check. Alright, so you have to watch out for those, because you don't want to include an extraneous number in your final answer. So let's take a look at this first example. Alright, so what we're going to do is we're going to solve square root of 2x minus 3 equals 9. We want to figure out what x value makes this true. So the first thing that I want you to notice in this one's actually like laid out very nicely for us. The radical here is completely isolated. So if I separate this into the left side and the right side, there's nothing but a radical. Now there are numbers and variables inside the radical, but outside of the radical there's nothing there. And that's what we want. And sometimes you'll see, on either side of the radical, another number or maybe even another radical. You only want one radical on one of your sides. Alright, so it doesn't have to be the left side, it could be the right side as well. But the way that we have it right now is ideal because the isolated is already completely isolated. Okay? I'm not sure if I said that right. The radical is completely isolated, just in case I didn't say it right. Now, here what we have is a square root. So the index is 2. So what I'm going to do is I'm going to raise both sides to the same power as the index. So I'm going to square both sides. Okay? And what that does is, at least on the left side, the square cancels out the square root. They're inverses of each other. They're opposites of each other. So just those symbols cancel out. So now what I'm left with is what's inside the radical, 2x minus 3. And on the right side, I can just do 9 squared. 9 squared is 81. Alright, and now this is a problem that you could probably do when you were like in 7th grade. So we're just going to do plus 3 on both sides, right? It's just some basic algebra. And then we have 2x equals 84. We're going to divide by 2, and we get x is equal to 42. Okay, now before I box that in or circle that as my final answer, I have to check, because it could be possible that this one answer that I got is extraneous. So let's go ahead and check it. I'm going to rewrite my original equation, which was 2x minus 3 equals 9. So what I want to do is I want to plug in 42 in for x, and I want to see, does it actually equal 9? So let's go ahead and do that. So 2 times, and in place of that x, I'm going to put 42 minus 3, make sure it's all under the radical, and here we're asking, is it equal to 9? Alright, so let's go ahead and do the math. So 2 times 42 is 84, and 84 minus 3 is 81. So the square root of 81, alright, well the square root of 81 is technically plus or minus, right? Positive or negative 9. But we're just going to take the positive value for it, because they're not specifically telling us to take the negative answer, or else they would have a negative out here. So you can assume we want the positive answer. So this is 9, and that does equal 9. That checks out. So because we checked it, and it all came out to be true, this x value is an answer, and that's our final answer. Alright, let's take a look at another example. Let me go ahead and do this on a new page. Alright, so we have example 2. We're going to do solve the square root of 4 minus x is equal to x minus 2. Okay, so we can see that on one of our sides, and specifically the side where the radical is, that left side only has a radical. And again, yes, there are terms inside the radical, but there's only one big radical. There's no other number, like this doesn't have a coefficient, there's nothing adding or subtracting on this side outside of the radical. So we have our radical isolated, which is what we want. So let's go ahead and raise both sides to a power that's going to get rid of that square root. Well, this is a square root, so the index, the little number here, is technically 2, so I'm going to raise it to that same power. Okay, so now these two things cancel, and what I'm left with is 4 minus x, because that didn't cancel out, and here x minus 2 squared. So if you want to quick do that, maybe you remember the shortcut. If you do, that's great, but we're just going to distribute here, right? And we're going to get x squared minus 2x plus 4. So we end up with x squared. We can combine these like terms, minus 4x plus 4. Alright, so let's go ahead and just start combining more like terms. I'm going to do plus x. So I have 4 equals x squared. Negative 4 plus 1 is negative 3. Alright, and then I can do minus 4 on both sides. I want everything on one side. So now I have 0 equals x squared minus 3x, and those actually canceled out on the right side as well. Okay, so the reason that I want everything set to 0 is because now I want to factor. If you want, you can flip the order here. Alright, and so I'm going to go ahead now and continue factoring because I have multiple x's. So I'm going to factor out an x here, and I'm going to end up with x minus 3 equals 0. And if you remember from our last unit, maybe even 2 units ago, what we want to do is we want to set up an equation and solve for each of those x's. So I'm going to set x equal to 0, and there's no solving there, x equals 0. And then I'm going to do x minus 3 equals 0. We're just going to add 3 to both sides, so we get x equals positive 3. Now, before we can actually circle those or box those in as our final answers, we have to check both of them. So the first thing I'm going to do is I'm going to check x equals 0. Alright, so I'm going to use my original equation. I'm going to do 4 minus, and I'm going to plug in 0 because that's where x is. And we're going to see, does that equal, and then on the right side, originally I have, I added the parentheses and the squared, but originally this was x minus 2, so I have 0 minus 2. Alright, so let's go ahead and see. 4 minus 0 is 4. The square root of 4 is 2. 0 minus 2 is negative 2. Well, that doesn't check out. So what that means is that 0 is actually an extraneous solution. It's not an actual answer. Well, let's go ahead and see what happens when we check x equals 3. Alright, so let's go ahead and plug into our original equation. So go back to the problem and plug in. So 4 minus 3, we want to figure out, does that equal the right side, 3 minus 2. So 4 minus 3 is 1, and the square root of 1 is 1. 3 minus 2 is 1. Okay, this one checks out. That means that the only answer is x equals 3. Alright, so you don't have to say that x equals 0 was extraneous. You don't have to say anything about any. You don't have to use the word extraneous in your solution at all. Your final answer will just look like this. We're going to completely ignore the fact that we actually did find an extraneous solution. We just want to disregard that completely. Alright.